Hi everyone, my name is Josephine Kizza. I'm the Executive Director of St. Jude Family Projects, but also a founder together with my late husband, John Kizza. I would like to share with you the background of St. Jude Family Projects. This started as a family farm due to the 1986 war that brought in the current government. We had to leave the city to come to Masaka, where both of us are born, to bring some help to the parents. In the due course, we were caught up in Masaka. On our way back to Kampala, we found a bridge crossed, the one that joins Masaka with the Kampala. It had to be dismantled so that the rebels could not cross over to Kampala because the war started from Masaka. So we had to come back to Masaka, but we had nothing on us, not even money left on us. I had only 2 dresses and my husband had 2. And on our return, my husband thought of going back to his parents' home because we didn't have any other home where we could stay. But because my husband's grandfather had given him land, I tried to convince him just to go to the land which was all in the bush, so that we could start life afresh. It was very hard to convince John, but at last he accepted, and we stayed in this bush, just putting a small shelter, and that's where we stayed for the first 4 months of our time in Masaka. And so we came back, and I requested my father-in-law, who had a pig that had just furrowed down, to give us 2 piglets because I realized the soils were so much depleted. And he was kind enough, he gave us 2 piglets, a male and female. We didn't have any ideas about the inbreeding, so we just took them on. And because we didn't have enough money to make good shed for these piglets, we just collected all the sticks that we came across and made a simple one. But as long as we could collect the manure from that. So it was very, very great for me because we were able now to grow some food, and this was only for consumption, for our home consumption. After a period of 1.5 years, we are able to realize other farmers around us that were keeping pigs. And what we wanted was to learn from them. So we were able to always visit and collect some knowledge from them. They taught us how to feed the pigs, but the problem now was how could we do it because we didn't have the money to buy the feeds. We continued with the local feeds that we could collect, like grass and weeds, and that's what we continued feeding the pigs. But after a time, we realized we had enough piglets, and we wanted to sell them off at once so that we could buy a heifer. We had a lady friend in Kampala who sold us an 8-month-old heifer. And this was majorly to do with enough manure. It was good that we got enough manure now. And after 1.5 years, this was able to give us at least a calf. And so we could buy milk. We could sell milk and get some money, which money now we saved to build our first house. And the first house was made out of and bricks, but with just mud because we didn't have enough mud. We thank God this cow continued giving us more milk, which we sold and got money to expand on other projects like the piggery. And that was also good enough because we expanded it and then brought in local chicken. And so now we wanted the members around us, the farmers around us, our neighbors, to come and learn from us. Why? Because both of us were teachers by profession initially. And so it was always very good for us to teach more people. More people came, and in 1992, that's when we heard over the radio that there was a training about organic agriculture, something we didn't have any idea about. But because from day one we worked as a couple, we always wanted to work, to discuss issues, to work as a family. So we decided together with John that I took the training, a one-day seminar about organic agriculture. And it was in Kampala, and I went, and all that we learned that day was about making compost manure, which was very important for me because of the soils that were very much depleted. And when I returned the following day, we did it together with John. And after 2 months, we saw the results. We applied the manure on the few banana plants, and it worked so well. So I was so amazed, and I wanted other people to learn from us. This is what continued up to today. So when other people learned from us, they always implemented. The first thing that was shocking was the fact that the ones that came and learned from us the first time, a few of them implemented, others didn't think it was very important. So in 1993, early, the lady that had sponsored that training in Kampala of organic agriculture came back to Uganda to just follow up a few of the members that had implemented. And I'm happy I was among the people that were chosen to be visited. The lady was so much impressed when she found me training 2 other ladies. And so she asked my husband whether he could let me go to the England, UK, to have a 2-year degree course in organic agriculture. My husband was very positive, and so in April 93, I had to go to UK for this training in the Reading University, which I did for 2 years. My husband stayed with the young family because by then we had 3 children, and the youngest was only 1 year. So he stayed back with them, and I went to train in the UK. When I returned, the first student in my class was my husband, which was also very good because he took almost over everything that I had learned there. And that was the time when we turned the family farm into a demonstration farm. We had to train other people. We wanted other people to learn from us, but learning from what we had demonstrated. So the family farm now turned into a training center, into a demonstration. We put a small shelter for people to come and learn from us. And ever since then, the last 25 years of my life, I've spent it training other people that come to St. Jude to learn from us. And that is when we set up an NGO called St. Jude Family Projects. And that under St. Jude Family Projects, we have many other aspects. The training center itself has many arms. First of all, we train farmers on farm with the demonstrations, but also we have a training center that we've set up whereby people come and learn and stay and, take some time with us learning. This is the St. Jude Family Projects and Integrated Organic Agriculture. Then we also have St. Jude Biointensive Center, so that the one who cannot take the permaculture or who cannot take the agroecology can also go and see what is also done at the biointensive and they learn the skills and practices that are set there.
Hello everyone, I'm Daniel, a trainer at St. Jude Family Projects. Today we are going to look at our biofertilizer facility at St. Jude Family Projects. I will start by explaining or giving a slight insight about what biofertilizers are. Over the years, organic agriculture has been characterized by the use of organic fertilizers in its day-to-day running. But slowly, many farmers have realized that organic agricultural fertilizers lack when it comes to microbial activity or when it comes to microbial-organisms in the soil. They have them, but they are very much limited in number. So biofertilizers came in handy or came in as a solution to address the lack of microbial-organisms in the organic agricultural fertilizers that were being used. In these three tanks, we have different types of biofertilizers that are being synthesized. For example, the very first one here, we have extraction of nitrogen that is being done inside it, and we are extracting nitrogen from animal blood. Abattoirs, people collect blood from abattoirs, and that blood is very rich in nitrogen. The hemoglobin is way too much prominent, and we need to extract that hemoglobin by using many different enzymes. The very first enzyme is papain from pawpaws, which we actually put inside here so that it can help us break down the hemoglobin. Then bromelain from pineapples, raw pineapples, is also added, and also ethanol. And in the long run, we have nitrogen extracted after 21 days. The next one, we have humic acid. This is humic acid that is extracted from humus, from just the environment around the farm. We collect that, we put ethanol, and then we incorporate everything within, and then after 21 days we have humic acids that are really very vital in use in the soil because they aid in adding vital acids that are responsible for allowing enzymatic action in the soil. Here we have this. This is actually, we are extracting microbes that are really very much important. So native microorganisms are extracted here. Any biofertilizer lab should have this. Now this is the old one. We have the new one that is still locked up inside there. We do that in phases, and when the old one gets expired, we use it now as a source of humus in the soil, which is really very vital to allowing soil fertility to prevail. So we are now going on to the next one, which is Spermagro. Spermagro is one of the best soil reconditioners that is required to help plants actually perform. It carries a number of lactic acid bacteria and a number of Escherichia coli and Salmonella typhi because of the components in which it is made. It is made out of cow dung. Cow dung is collected from the animals, like you always know. We have zero-grazed animals on the farm. So we collect cow dung and then we use it to actually come up with this. Cow dung has a number of important microbes that are required in the soil, like Nitrobacter, Escherichia coli, Lactobacillus. And then as an additive, we also add milk. Milk, because it is rich in lactobacillus, is the very main inoculant of lactobacillus that we require inside here. This lactobacillus goes into the system and eats through the spermagro that we've made to actually help expose the nutrients that are inside it so that they can actually go into the soil and be utilized further by the microorganisms inside. Here, we actually have to add water. We have to add milk, we have to add cow dung, and then keep commixing until we get a paste-like substance that is now utilized after 3 days into the fields where we require it to be used. So all these various biofertilizers that have been synthesized in the tanks must be tested before we roll them out to the various gardens that we have at the center, or various test gardens. So what we do, after collecting them from the other tanks, when they are ready, we bring them down here and start carrying out different tests for different amounts, for different crops, for different biofertilizers, and then later on we can carry out an analysis and find out what is performing how and under which amounts before we actually advise our farmers that you should use these quantities for these and these crops in their fields. One of the most important biofertilizers that has been very, very much influential and essential in helping us in the field, especially in reconditioning the soils of most of our extension farmers, is bokashi. My colleagues here, especially Godfrey, are going to take you through a session in how bokashi is made and how it comes up as an end product that comes in handy to substitute compost manure, which is an organic fertilizer. Thank you very much. Godfrey, take on.
You're welcome. Thank you, Daniel. Now I'm going to take you through the procedures and the materials that we do use in making the bokashi as a very fundamental fertilizer. Let me first explain what is here. We are having poultry litter here. We are having the blacker thing that is biochar, which is got from charcoal. We are having ash, the one he is mixing. Then we have cow dung that is on the other heap. Then we have maize bland. We are having the DHL. These are microbes that we do use to stimulate the performance of the bokashi. Then we are having sugar, which is the sugars that we have, and they are the ones that we keep mixing in, so that these microbes, as they are growing within the procedure, they are getting what to eat as sugar, and they get energy to produce the real fertilizer that we get. So how do we perform it? Now we are going into the real practice of mixing the bokashi as it is done in the practical part. Now we have started with ash, as laying it a layer like this. Then we put maize bland on it, and then we get the sugars. We wet it like this. After putting the sugars, we shall add biochar on it, as if we are making a profile. And after this, we shall have cow dung. We shall have cow dung mixed up on it. Then after, I'll get yeast, and then I put on it. When you put, again, you make sure that you wet it, but not too much. It should be 50% wet. And after this, I'm getting the poultry litter here, and then I mix it on it. Then I continue the process of ash. Then I bring the biochar again, mixing it on it. Then I wet it with the sugars. Then I'm putting cow dung down to create a balance within the mixed up concentration of the bokashi. Then I put the feed, which is maize bland. Again, I put a stimulant, which is the yeast, and which will break down the carbohydrate of sugars. Then I add again the poultry litter. Now the process is going to continue up to the time that I finish up all this, which is around here. After this, we shall keep turning this. We shall keep turning it like this after the whole process of consuming all what you see here. So we keep turning it like this. What we are looking for is removing that deficiency in the fertilizers that you see here, so that we can have a completely balanced fertilizer. So when we turn it like this, we shall keep the heap. After well turning, we shall keep the heap like this and see the moisture content. Once it is 50 like this, we keep it for some time. Now, if you've done it in the morning, you turn it in the evening. You turn it once, and again you turn it once. So you keep turning, and this will be ready for after 13 days. So this one, it is the best because you can time it, and it is not time consuming as it was before, as we are doing the composite fertilizers. So this is the best way we do it here at St. Jude Family Project, and it is the one that we use in our group of farmers around us, the groups that we work with. So this is the presentation, the simple presentation of how bokash is done.
So from down, you've seen that we've seen a number of other biofertilizers down there, and this is also another one that is very cheap to synthesize on the farm. Vermicompost juice, vermicompost biofertilizer, I mean the solid part, can easily be done on a farm by any farmer, and it can help also recondition the soil easily because they are easy to feed. I mean the vermicompost, I mean the worms, and also the cow dung that comes off as a result of cattle day-to-day practices can easily be used to synthesize a number of other products, byproducts of vermicompost that can really be very, very important in reconditioning the soil and also acting as a foliar spray. Hello everyone, I'm Daniel, a trainer at St. Jude Family Projects. Today I'm talking pigs, and we are going to see our project at St. Jude Family Projects and how it has been able to transform communities. So as you all very much see, around the place where we are, we have a piggery project that is roughly, the population of the pigs we have at St. Jude are around 85 pigs on the old center or main center. And these ones are actually being used for breeding purposes. So we have this section here as a breeding center for the pigs that we supply on all our 8 farms that we have as a farm. And again, still after they have, after breeding them here, the offsprings are actually used to transform our extension, to actually transform the livelihoods of our extension farmers. How do we do that? We give them a piglet. Each farmer has a chance to receive a piglet. In most cases, we serve them out as pairs, a male and female of actually different progeny. After giving them out to our farmers, they use them to actually make money by starting up their own pigsties. One of our principles is zero waste. We have to make sure we don't waste anything. So pigs can easily be fed by even the most poorest farmer. Most of the farmers we work with are poor, so they need projects that are going to kickstart them off. So we have 5 different types of pigs that we rear on the farm. We have the large white, which is actually basically it has a longer body, it is raised off the ground, it is actually taller than all other breeds, and it has the ears pointed upwards. Those are the characteristics of a large white pig. And then we have a landrace pig. The landrace pig, the ears droop closer to the eyes and they actually cover the eyes. They have a shorter snout and they are short in length. They are short in height, sorry. And then the body length is also a little bit shorter. So that is a landrace. Then with a large black, it's prominently black and fat in size and also with a shorter body. And then with a saddleback has a white stripe all through its body. And then we have the Cambluff. Cambluff is basically a mixture between large white and landrace. It is way too much lifted off the ground. It's taller in body. It has a lean fat content. Its meat is actually very low in fat content. Doesn't have that subcutaneous tissue that is way much prominent. And its growth rate is way much faster than all other breeds. So that's why most people in Uganda prefer Cambluff compared to any other types of breeds. But also the other breeds have many other advantages that we shall see around the farm. Then we are also going to be able to see how the feeding practices are done, how we do it, and how the injectable and medication practices are done. So medication is one of the most important practices that we carry out on a pig farm. So we have to medicate pigs on issues to do with mange. We have to medicate pigs on issues to do with supplementing their feeding through multivitamin application in their body. We apply multivitamin through you can use injectable solutions, or you can actually mix within the feed of the pig. So what we basically use here is the injectable. So he's going to apply multivitamin, and it's always injected just behind the ears of the pig, like he's going to do. And on top of that, there is this almycin, which is really very important. It's a fly repellent, and it also helps seal. It has a fat layer, or it has some oil substance within it that helps actually seal the wound of the animal. And that way, the wound can actually start healing without necessarily having to be bruised again, and flies taking over the wound and actually causing septic conditions to develop. So it basically prevents sepsis from happening on the skin of a pig, and also prevents the pig from having uncomfortable situations with flies coming in, and also creating a condition of restlessness in pigs.
I'm Kembo Herbert, a trainer at St. Jude Family Projects. located in Masaka, the central part of Uganda. Today I will be basically talking about coffee, how it's grown in Uganda, and the different types of coffee which are grown in Uganda. In Uganda, we basically have two types of coffee. We have the Robusta and the Arabica coffee. Robusta coffee is grown in the lowland areas of Uganda, whereas the Arabica is grown in the highland areas in Uganda. So basically here at St. Jude, we are basically concentrating on the Robusta coffee because this is the lowland area located in the central part of Uganda. Robusta is propagated either by seed or by cuttings. So from the seed and cutting, you can get the seedling, and it will take you basically 2 to 3 years to get to start production. So after the 2 to 3 years, you will start having the first stage before flowering, which are the spikes. From the spikes will blossom to have the actual flowering. The actual flowering, just because it's a bit dry, but they were always whitish in color. So after the flowering, we shall go to the pinhead stage. At the pinhead stage, this is the most safest part of the stage of the coffee stage, because you can never get any effect of drought or any effect of thunderstorms, because this is very safe. Even if you have a short drought, this will always remain because they're really very, very strong to be on the tree. So from the pinhead stage, we shall go to the expansion stage. At the expansion stage, this is the stage where the actual berry is making the actual size of the coffee. It is determined at this stage. This is the stage where you need the nitrogen, where you need the phosphorus. Nitrogen to improve on the size of the bean, the cherry fading, and also the phosphorus, which will improve the flavor of the coffee you get as the final product. So after the expansion stage, when we have actually got our size of the bean will start hardening. At the hardening stage, you can even feel it's very, very hard at this stage because the seed is being made inside. So after the hardening stage, we shall go to the ripening stage. At the ripening stage, this is the stage where after the hardening stage, it will ripe basically. So it will be harvested at the ripening stage. After the ripening stage, we shall dry actually the red cherries to get the dry cherries. Basically, our drying here in Uganda is through tarpaulins. We don't really have mechanized drying in Uganda for Robusta. So after we have got our dry coffee, locally here it's called chiboko, we shall take this chiboko or the dry coffee to a harale where it's held to get the FHU. FHU is not the best quality because we shall have non-coffees coming along, just for example stones and the hussicks. So after the FHU, that's why we call it the fairly agreed quality. So it will require more processing from the FHU to remove the non-coffees, basically the stones and the hussicks. So after the processing of removing the stones and the hussicks, we shall go and roast our coffee. Roasted coffee, it can be roasted at different temperatures according to the quality of the coffee you want. So roasted coffee just looks basically like this. So after the roasting, you'll grind your coffee to have the fine actual coffee. So that's the entire value chain of coffee in Uganda. One of the major problems we have in Uganda is the black twig borer. It's one of the major pests in Robusta, which attacks the entire branch. It comes and bores holes in this primary branch, and when it bores a hole in this primary branch, it will entirely wilt. So the entire crop is lost. So it's one of the biggest challenges in Uganda. Then the other issue we have in Uganda is the price fluctuations. You find that, for example, last year we had a price of 4,500, and this year we have a relatively very low price. It's depreciating over by 500 shillings to 4,000 between 3,900 to 4,000. So those are one of the major issues we have in Uganda. Thank you very much.
My name is Ntambazi Richard. I work with St. Jude. St. Jude is found in Masaka, in Uganda, Masaka District. One of the projects we carry here is cattle rearing. So it's what we are going to look at. We are going to cut this in 2 stages because we have the feeds. Then from the feeds we go to the corral where we keep these animals. we have the feeding boxes, we have the drinking trough, then we have the exercising area, we have the milking crush, the spraying crush, then we have the beddings and the exercising area. When we come to the feeds, we have hay, which is it includes alfalfa, it includes we have coriander, which is here, we have sesbania, we have napier or elephant grass, and then we have also maize bran. With this, we also have this molasses, which when we dilute it and spray on this dry feeders or the hay, and then we provide to the animals. This molasses contains carbohydrates, which will also help these animals to have energy. And then this is the bran, maize bran. We just give the maize bran to the animals. We can even mix it in water. They take it when it is in water, or they take when it is dry, they lick. Then they take a lot of water and then they go and rest. After feeding them, well, they are now satisfied. They need to take water because they are thirsty. They will go to the drinking point there. They drink water. And on top of water, we can add maize bran so that it to appetize these animals to take as much water as possible. And these animals have to take a lot of water. Each animal should take at least 3 or 4 jerrycans per day. So from there, they will just come here, they urinate, they defecate. It's where now we also go and collect this dung and urine. The dung is mixed with the urine. It will pass there and go to where we make biogas from. Then from there, down there, here we have the beddings. The beddings, we just put grass there so they have to sleep in a comfortable place. That's where they sleep from and they rest from. Then from there, we also have the calf pens. When these animals produce, they have the calf pens. The calves are kept inside there. And we also, these calves, we feed these calves on their mother's milk, but they take milk from the pails. They don't just go to their mother's udder and get milk. They will just put milk in the pails and we feed them on milk which is diluted. And then there we also have the spraying crush, where when we want to spray them, we spray them from there to prevent ticks or to kill ticks that have attacked these animals. Okay, that has been inside here. Now from here, we are going to the biogas section, where biogas is manufactured from. So as we have seen everything taking place in the cloud, now we have come to the biogas production. So I want to hand over this session to Daniel to take you over.
Thank you very much, as my colleague has been explaining to you earlier on. The entire process of biogas production starts from the day a cow receives food in the feeding boxes. So all through that entire process, even through the stomachs, the digestive system of a cow, it is all actually aiming at producing gas, which gas is methane gas, which we want as a byproduct in helping us cook. So we start off with the stomach of the entire cow. A cow has 4 stomachs, as you all know. We have the rumen, reticulum, omasum, and abomasum. Now, all these 4 stomachs are actually a source of biogas production. First of all, when a cow eats, it eats heavily, foods that are so heavy in sugar. We have hemicellulose, cellulose, lignin, and all these other, sugars that are embedded within a plant when it's growing up. So because a cow feeds on heavily embedded, food crops with sugar, a cow has a lot of, it has a lot of gas that is produced during the process of digestion. So it's that gas that we are going to trap off and utilize it for other purposes like cooking food and many other, lighting and all other related processes. So as we are going to see now, the dung is coming from the kraal and is coming down into this. So down here, we are going to start off or to kick off the process of biogas production. as I'm going to show you. So in the morning, after the day-to-day standard cleaning procedures of the kraal, all the dung collects inside this mixing tank. We bring it through, come through that tunnel in there, and then collects inside here with all the water, with all the urine for the day, for the past day. So when it reaches here, we have to ensure that all this fibrous matter is collected out. This is fiber which ends up blocking the biogas system. So we have to make sure it is removed from the process. And how do we do that? By ensuring that we commix dung alongside the urine, alongside the water that comes inside here. And so that dung, after mixing very well and removing all the fibrous matter, turns into what we call slurry. Now slurry is that porridge-like substance that comes out, after you have mixed everything together, and then you end up with some kind of, thick slurry-like substance which is similar to what porridge would look like. So that's what we actually need for our biogas process. So because that cannot block the system, we take it from this point. After removing all this, this is an enclosure that is holding it together. I can't open it now because it's not the mixing time. We mix in the morning and then we have the slurry flow into the dome for the day. So after mixing that, we open this chamber here, and it will start flowing from this chamber to this point here. And it's from this mixing chamber that we are now going to have our porridge-like substance that was mixed here flow down into the dome. And to have that, we need to open this chamber. So we shall open this chamber, and it will start flowing from here, coming down here. When it reaches this point here, we now have to let way for this slurry to flow into the dome. And how do we do that? We do that by moving this pipe up and down, up and down. As we do that, we're actually creating pressure to allow the flow of substances from here all the way to the dome, the other side. Now, this pipe that I'm trying to move up and down helps us actually create pressure, suction pressure, that will allow the slurry to flow from this point all the way to the dome, the other side. So as I move it up and down, you realize that bubbling is taking place, and actually there is a slow process of flowing of slurry from this point all the way to the dome. So now we have our slurry already in the fermentation tank or the dome. So what is taking place basically there is the process of fermentation, whereby we are having complex sugars being reduced to much simpler sugars, of course with heat as a catalyst. So inside there we don't have any area that is letting in air, because on top we have clay, we have water, and then we have a dome. So because there's no air inlet, there is a lot of heat build-up. That heat build-up is allowing microorganisms to start the breakdown, and now we are having a byproduct, which is methane gas collecting on top. We have water, and then we have entirely heat as another byproduct. So from there, after gas has gone up, gas follows that pipe. It's the only outlet going up onto the kitchen area where we use it for cooking purposes, and also where we use it for lighting purposes in case someone wants to light their houses. Later on, we are planning to also use it for engine purposes, so we can run it in an engine and then produce electricity on the other hand. But that done with the old slurry that is way much less dense will remain on top of the new slurry that is still dense, because it has a lot of gas that is still embedded within. That old slurry will all come closer to an outlet that is close there, and that outlet will now allow it to flow from that point all the way to this dome. The dome is the exit dome, the slurry dome basically. So when it reaches the slurry dome here, it will now start off the process of moving all the way the other side. But in case there is a blockage, I need to pump that old slurry out. And how do I do that? By creating suction again, like I did the other side. I just simply come in here, use this simple pipe here, and continuously pump. And as I pump, and I feel like it's rigid, then I know there is a blockage. But if at all it's flowing the way it's doing right now, then that means the slurry is simply coming out. And if I was to do this thing again and again for a number of minutes, you will start to see the slurry actually flowing all the way the other side. But for the interest of time, I will move on to this last part here. So inside here, we are having the old slurry flow. Because the new slurry is coming in, this old slurry will flow automatically all the way here. And when it reaches this point here, it will now start flowing out automatically, slowly by slowly. And because it's flowing out, I now start to examine it. Being a farmer who doesn't want to lose anything, I can still utilize this slurry for a number of other purposes. I can use it as a top dressing for my gardens. I can use it as a feed for the worms. I can use it as a feed for the fish. I can dry it and even roast it on fire and add it in maize bran, and I use it as a feed for the pigs. Because it's just simply cow dung that only has those vital, microorganisms that are not that dangerous. But when I'm roasting on fire, then I have to make sure I raise temperatures to 160 degrees Celsius for 30 minutes so I can kill off the Salmonella typhi that is dangerous to pigs and human beings. And for that I can easily do, and then I can feed my pigs so cheaply without necessarily having to spend money on buying feed for the animals. Again, still after doing that, I have this outlet to show that after it has all reached here, it has to flow all the way from this point to the gardens where I can use it in contours, and I use it for purposes of keeping fertility embedded within the garden.
Hello everyone, my name is Jimmy, a trainer from St. Jude Family Projects, which is found in Masaka District. And this episode we are going to look at two projects which are undertaken here at St. Jude, and that is aquaculture and apiculture. And to set the ball rolling, let me begin with apiculture. So apiculture basically is the science of keeping bees. We know bees are social insects which live together in organized colonies. And in bees we have three types. We have the queen, which lay eggs. We have the drones. These are the male bees, and their main purpose is to mate with the queen. And then we have the female sterile bees, and these act as the workers. And we know they live in the environment, they live together in the environment provided by nature. But we can bring them to be part of us on a farm, and we create artificial environment for them, and these are the hives. So we have very many types of beehives. We have the traditional hive, commonly known as the Kigezi hive. We have the Kenyan top bar hive, which is square or in a box form. Then we have the Ugandan top bar hive. This is triangular. When a number of hives have been made, then we choose a suitable place to set up the apiary. This place must be cool because bees don't like a lot of heat. And secondly, they need an environment which is silent. They don't need a lot of noise. They are disturbed by a lot of noise. So after we have made a number of beehives, then we set them to that place. And bees need water. So that place must be near the source of water, and it must be surrounded by flowering plants or plants which bear flowers, just to ease their movement from moving long distances looking for flowers to collect nectar. So after we have done all that, then we transfer the hives to that place, and we ensure that that place is having a source of water, and then the crops we grow around are able to provide bees with nectar because they flower. And in due course, we know the uses of bees. They carry out pollination, which encourages fruiting and then more yields. And as we know, farmers grow different types of crops as well as trees for producing fruits and the like. So bees become part of our system because our system of farming is organic and integrated. That's why bees come in to do that part of pollination. Now we have two different methods of stocking the hive. We can smear inside the hive with honey. Because these bees are very sensitive, they can smell the honey and then come. As I told you, because they live in organized family colonies, they can take back the message to other bees that a new place has been located, and then they will swarm and then occupy that beehive. Secondly, there is another method which is known as the swarm catching net. There is a net which you can use to catch that swarm, because when these bees swarm, they move long distances and then they rest on tree branches. So if you sight where they are, You bring that net, then you open it, then you trap those bees, and then you bring them, and then they will occupy the hive. Now, when the beehive has been occupied by bees, it takes about 8 months before harvesting is done. And normal harvesting is done in June, July, in the dry season. As I told you earlier on, that bees need water to make honey. So this place here where we are now acts as a water source for the bees. But on the other hand, we also use this pond to carry out fish farming. So this is one of the ponds that we have. This is the artery pond. It is dug in the ground, especially in an area where the water table is low or in the valley. So as you can see, it is down here. This is a hill. So water drains from up there and then feeds this. We have the catfish, and we have about 1,500 catfish in this pond, both males and females. But they don't breed under captivity. So the number we put in the pond is the number we expect when we harvesting.
My name is Kavuga Expedito Buyanja. My colleagues shortly call me XP, and I welcome you to the Banana Agronomy Project at St. Jude here in Busense, Rukoto, Masaka District in central Uganda. In here we will talk about briefly what banana is in this country and the work we've been doing at the project promoting improved agronomy to small-scale farmers so they can improve their productivity. About banana. Banana is synonymous with food in this country because it's the major food crop. In Uganda, we consume on average about 200 kilograms of banana per year, each person. So it's that important, and it's grown in this region, in central, southwestern, in eastern, and other parts of the country, especially where they receive 2 seasons of rainfall. A brief about banana as a crop. Banana is a perennial crop. It's a herbaceous plant that in its well-established form will have heterogeneity. You have a mother generation with a daughter generation and normally a granddaughter generation, and all these are controlled by the management of the farmer and the objective that they have. One advantage of this banana as a crop, first of all, it's a major food crop and it's a good food security crop because of that heterogeneity. It will give you a year-round harvest, and so it keeps the household secure, food secure. But as well as a commercial crop, then the farmer has what to sell all through the year. From here we will go to the demonstration table, and where I'll talk about the growth requirements of banana as well as the production constraints and how these inform the banana agronomic management. So we go to the table. First of all, where to grow banana. Banana would grow best in a place where there is deep, well-drained, fertile soil. And that, of course, would be the ideal. But it also helps us to know that if the soil you have does not measure to that standard, then what do you do to amend? And then, subsequently, when you establish managing the banana to maintain the generations that we have had a look at. So, starting with how to establish banana, there are different planting materials that we can use to establish a banana plantation. First of all, if you have access to a banana tissue culture lab, you can make use of banana plantlets. These are tissue culture plantlets with an advantage that they are normally true to the type, and secondly, they are clean, free from pests and diseases. In case you have no access to banana tissue culture labs, you can then use established banana plantations, and you pick planting materials from there. A sword sucker has sword-shaped leaves, and it has a profound comb which is rich in food reserves that can support the plant to establishment. In contrast to a water sucker, this normally results from pest attack, or it happens to come from a comb from which the mother plant has been harvested. So when you source this very clean planting material, first of all, it should be healthy looking from the start, and then get the good sword sucker and harvest it, get it off the mother plant. But it's not yet ready for planting. You got to do what we call pairing to get a super clean planting material. This is how you go. You have to remove these dry leaf sheaths and leave the fresh ones untampered with. Afterwards, cut off all the roots. This process of cutting the roots saves us two major pests. One, the banana nematodes, which are burrowing nematodes that are found in the roots. Secondly, the banana weevil. A banana weevil normally attacks the comb and it tunnels, thereby causing damage. So when you do this kind of pairing until we get to such a well paired comb, you'll be able to see a comb which has banana weevils in, and then you will discard that or cut off until you get to clean tissue. And as well, you would have left the nematodes in the field where you are picking the planting material. So when this is to be established, then we look at things of plant density and then the spacing. The spacing of banana is 3 meters by 3 meters or 10 feet by 10 feet. And then the size of the planting hole is 3 meters by 3 meters, and then 3 feet by 3 feet, and then 2 feet deep. And there you go, you've established your banana planting material. But as you are planting, it is important to start right away the nutrition, because banana is a highly nutrient demanding crop, demanding plenty of potassium especially, but also nitrogen and phosphorus. So hence the need to apply organic fertilizers right at planting. And with me is a sample of farmyard manure. This is one of the organic fertilizers you can use. You can also use compost manure. So 18 kilograms of farmyard manure or 2 basins of farmyard manure are enough for establishment, and it can take you up to the first harvest before addition. So from here we are going to have a look at an established banana plantation and how to manage and sustain it. So at this point we are going to discuss the management of an established banana plantation. And first of all, managing the mat itself, ensuring that it has the adequate number of suckers. Like we said, you should have the mother, the daughter, and the granddaughter. And if anything, you can only increase this number to 2 families. Namely, have 2 families of a mother, a daughter, and a granddaughter. But then that has a lot of implications on even the nutrition, because then you will have to double if you have 2 families. So start with the desuckering. Maintain the suckers and stagger them it's often that banana produces suckers at the same age, but always leave suckers of different age so that you can stagger your harvest across the year, and as well you reduce competition by suckers at the same size. After desuckering, reduce competition of banana with weeds for nutrients. So remove all the weeds and keep the banana free from weeds, just as we can see right here. The weeding in banana shouldn't be done using a hand hoe, and we will discuss a little detail of how to keep it weed free but without putting in a hand hoe, as it destroys roots. And having kept the banana plantation free from weeds, then the next step is how to conserve water in the banana plantation. In Uganda, most of the bananas are rain-fed, therefore we rely on maintaining moisture in the soil after the rain season. So this can be achieved through various methods, but much of it is mulching, keeping the ground covered. So we can use this, which is banana residue. The banana residue itself can provide some of the mulch. This is internal mulch that is generated within the banana. Once they are well fed, they'll give you a lot of biomass which you can use for mulching. As well, you can use external mulch rather, which then would be cereal residues, grasses, and others that can be used for covering the soil. So I'd like us to pay attention to the placement of mulch. As you can see in this plantation, whereas you need to mulch as much surface of the banana plantation, but then the 2 feet from the plant should be left bare. Reason being, if you have mulch near the plantation, you can see banana roots growing outwards, and which is not good during dry season, because then they can also topple off. Secondly, if you bring mulch to the banana plantation, to the banana plant, close the plant, you create an area that is moist and is dark, which is ideal for the banana weevil, which is a major pest. And then, well discussed them, we have looked at how to conserve water in the plantation, and now conserving nutrients in the plantation. Remember, every harvest nutrients. So we have to replace the nutrients that are lost. For farmers are generally using organic materials, and there you have to apply at least a basin of well decomposed manure every year to compensate for the nutrients that are being reduced. And for farmers who can do integrated nutrient management, they can also consider application of inorganic fertilizer, especially potassium rich fertilizer, muriate of potash. And with that, combined with a basin of manure annually and muriate of potash, you can maintain your banana production. In this part of the plantation, we will have a discussion about the constraints, the production constraints. And right here is a perfect example of one major pest of banana. This is the nematode, banana nematodes. There are about 3 species of banana nematodes, but what cuts across them all is they affect the roots, and so roots rot and the plant loses the stability and it topples. This is called toppling, where the plant falls with the whole of its base out. As opposed to snapping, snapping would be caused by the weevils. You'd expect a banana plant, to fall just at the collar region. That would be because of weevils. And if it falls with the whole comb, then that would be because of nematodes. And if it falls way along the banana pseudostem, that would be because of wind. So those are pests. And currently, the methods of control of these pests vary. For nematodes, as majorly if you could start clean, like we explained, start clean and start in a clean field. If the field is infested, you can consider using a fallow crop. If you plant a season of cassava, you'd clear out banana nematodes. And then you plant clean with a well-paired sucker. For weevils, still at introduction, do the sucker pairing to reduce introduction. But they come in as the plant grows, and therefore you can do culture management, reducing these combs, cutting when you harvest, cut off the combs and split them so that there is no breeding ground. And also as you are mulching, recess the mulch like we explained to avoid breeding ground for the weevils. And finally is the harvest of banana. If you are going to harvest banana, you take care not to injure it. So you cut it at a point along the pseudo stem, which is just high enough to ensure that when it will fall gently and only the tip touches the ground, so that when you cut it, it lands without being bruised. And at this point I would like to say that from the start of the planting up to this point will take you on average 12 to 14 months. Some cultivars are quicker maturing than others, but generally bananas of this type, which are called highland bananas or cooking type bananas, or East African highland bananas, which are food type in this region, will flower 8 to 9 months after planting, and then they will require 3 months of bunch filling, which makes it 12 months, about 12 months of harvest. Thank you very much.
Yes, I salute everybody that I work with in the poultry management at St. Jude Family Projects. I'm going to present the management and all the challenges and activities involving in management of birds at St. Jude. So I will start with the types of the types of birds that we do keep at St. Jude Family Projects. We majorly have 3 breeds that we do keep here. We have the dual purpose, well known as the croiler. We have the layer, which is known as the Rhode Island Red, and we have the broiler. So I'm going to first talk about them, then I talk about their way of handling up to the time of maturity, and then the result, that is the purpose. This is the croiler bird. It is dual purpose. It produces meat and eggs. So this one is kept purposely for meat and eggs. We have the layer. This is a specific bird, well known as the Rhode Island Red. It is a specific bird. It is well known for only eggs, and we keep it for egg production. So this is also the second breed that we keep. A specific breed also we have is here. This is known for meat only, and it matures very fast. In a few months we can have this as meat, as you will see here. So now I'm going to handle the procedure of a day 1 chick of all those 3 breeds. In a day 1 chick, we start with what we call a brooding room. Any room that we're organized with the principles that I'm going to talk about is called a brooding room. A brooding room requires to be cleaned and cleansed with the disinfectant. When you cleanse it, you make sure that after a while you apply heat to moderate the temperatures. When you moderate the temperatures, you take time like 24 hours, then you apply water in it. So the 1 day chick, we provide it with the water provided with glucose to provide energy for 1 hour. And then that's when we can apply the feeds. So this is the smaller drinker. We start with a 1 day chick, and this is where we put the water which has glucose, which gives it energy. The reason as to why we put some stones here, remember the birds are very small, so they keep falling here. So you put stones so that they don't fall here, but they just get water which can sustain them and give them strength because it is combined with the glucose. So this is the startup drinker for the birds. So this is the starter's mash. So this is what we start with, and this is the trough where we put the feeds, and then we apply. And when we put in the trough, you put a little so that their consuming consumption is low. You put little so that they can consume it and get finished. When they keep on growing, we keep changing their formulas. Then we put, after that starter, we put the grower's mash. That one helps the bird to grow firm, preparing itself for laying eggs. So when they reach 3 or 4 months and 1 week, we put layer's mash. When we put layer's mash, we expect the birds to be starting giving out eggs. So we continue having that feed on them. That is what the layers mash up to the time we assume that the birds are done with the laying. But again, within the process of management, there is what we call vaccinating birds. So they are drugs that we apply from a day 1 chick up to the end, or up to the time of harvesting. There is Marex, there is Newcastle, there is typhoid, there is Gombolo, there is but Newcastle, for it, we keep it doing it. We do it every after month. There is deworming. So those are the managerial skills that we do practice. But the simplest way, it is given by each company, and it is the one to guide you when and how. So that is how we manage poultry birds. There are some challenges within the birds that we do encounter. Failure to identify a clear company that supplies a real breed of birds, because when they are very young, it is very hard for you to detect which is which, and at times you may end up rearing a bird which is not complying to the production of the production that you really require, like egg production. And in bird rearing, there is a challenge of disease outbreak. At times you fail to get the real vaccine that can cater for such diseases that have encountered the farm in the due process of rearing. There is safety around, as people don't think that, as you know, areas where birds are reared, people keep on encroaching on people's farms, or on St. Jude farms, looking for such free opportunities. So it is also a problem that we do encounter. But there are also certainly indirect benefits that we do get, and one of them is, like, since we use a deep litter system in our rearing, we use this. After we get them from the coffee husks, and they are the ones that help us to control the wetness of the house. And this deep litter system that we use, we keep turning this with the droppings of the bird. And once you keep turning this, in the form way, that is how we form the purely organic manure that we do apply to sustain other projects, such as the gardens and the banana plantations and everything. So these are the indirect services that we do get, but not the one that we aim at when we are rearing birds. So in so doing, we are having this supplementing to our production and income that we get out of the birds. So when in rearing the red birds, so these are the products that we get. The size depends on how we have fed it, and the accumulation of eggs depends on the time, on how you pick the eggs, and these are the result that you always get. A tray of these eggs is having 30. That means you should have a number of birds there should be 30 to make a tray. And this is the cost of it depends on the demand, the forces of demand and supply on the market. So this is the end result. So when I talk about the meat production, where I talked about the broilers that grow very fast, this is the structure that we have now chopped one, and it is ready to be consumed. So this is the fresh that we get out of the broiler meat. and its carcass weight is very surprising and is very interesting. So the fresh is very good compared as you compare that this is egg production and this is meat production. So when we reach this carcass body weight, that means we have already attained our success, and it is encroaching 2 kilograms. So this can earn us enough money to cater for the management encountered in raising it up to this time. So this is the production, and I thank everybody who wish to join us in production of poultry management. Thank you very much. So inside here, in the poultry house, there are certain activities that we do apply here. This is the laying nest. This is where the birds go and put their eggs, as you can see. This is the products that I was showing you outside on the table. So they keep laying, and this is where the red bird that is laying comes and hides to lay its eggs. So its purpose is for laying birds. This is a bigger trough, as you can see, compared to the small one that I showed you in the brooder. So this one, it is more bigger because even the size of the birds have increased. So we increase even the size of feeding. You can see it is very long and it is very big in size. So in conclusion, we have all this done inside the poultry house, and you keep managing it and turning the litter, as I was telling you. You keep turning this litter, the coffee husks and the droppings up to this time, so that the wetness does not affect the birds with coccidiosis. And after all, after we have off-laid the birds, we use this as the organic manure to the bananas and vegetables that we grow at St. Jude. I thank everyone for watching this episode of Managing Poultry at St. Jude Family Project, Masaka District. Thank you very much.
Hi everyone, my name is Maurice from Africa, Uganda, and I'm in Masaka working with St. Jude. And I'm here to tell you about urban gardening. There are very many types of urban gardening, but we should first start with a description of urban gardening. This is a type of farming that is carried out by the urban dwellers. It's a type of farming to cater for those people that don't have big portions of land, but they would like to have somewhere to grow their crops. And this is done through very many different ways. We have vertical gardens, ring gardens, stair gardens, and in urban gardening, it has a lot of benefits like I'm going to name. There are benefits like food security, benefits that give you a sense of belonging, benefits that will give you everything you need, give you organic food, and protect you from some diseases, as well as improving your nutrition. One of the major principles of urban gardening is a principle of zero waste. In this principle, we have reusing, recycling, and replacing. Here we use things that could have been pollutants to the environment. For example, like you can see on my side here, we have tires that are old tires of vehicles that would have been pollutants to the environment, but we use them to grow vegetables. As well as plastic bottles are used as irrigation kits, so we don't need to spend much money in irrigating crops. Another principle of urban gardening is space utilization. We use every available space around us to make it productive by growing crops out of it. This gives us enough food security, in that if we have problems with food, we can never go out of food. We have 2 stations of urban gardening, and right here is one of it, and this is the St. Jude headquarters stations. And we're going to check out this here, as well as we shall check out the other one down there that will include sack mounds. For now, let's check out this. We have very many types of urban gardens, and right here with me is a stair garden. It's placed in a position that is strategic for it. It's under a roof, whereby water comes from up there and irrigates it, as well as we can improvise by putting plastic bottles to irrigate the crop itself. This is saving us the pollutants. We also mulch the garden to keep the soil wet and moist for the crop. But we also have some other urban gardens, and these include veranda gardens, all balcony gardens. So with urban gardening, we find ourselves in a position that we don't need to plant flowers that we're not going to gain from, but instead we plant these vegetables that we're going to eat to improve on our nutrition and diet, hence keeping us with food also, because it's part of food security. This is a contained garden made out of eucalyptus poles. These trees suck everything out of the soil, including the water, and replace it with nothing. So this leads the soil quality to drop. If the land was productive, this becomes unproductive, and so we get these trees and use their poles. We make them useful by using their poles to contain the soil in one place, fertilize the soil, and then turn that soil into a garden. Welcome to this other section of the farm, and this is the second section of the farm. This is where I told you that we shall see another type of garden, urban garden, and this is called the sack mound. It's done in this way because we need to put the soil together and have the same soil fertility over it, and you can see how productive it is. We have vertical gardens. The sticks that go up have a type of bean that is climbing. We have a couple of companion planting here. We have different types of crops that can repel the other pests of the other crops. So we find ourselves that we rarely even use any chemicals here to spray off the pests. So we use these bottles to carry out irrigation. And in this type of irrigation, we use the bottle that would have been a pollutant to the environment. And here we put it next to the plant root and fix it strongly so that it reduces the pressure at which the water gets out of the bottle. We go on to the next plant and we do the same thing. This enables the farmer to irrigate less with a watering can. It gives automatic action to the plant. It will sip directly from the water, and the water will last longer there. So we add some mulch to keep the plant moist and the soil moist.
But we also have the St. Jude College of Agroecology. We are trying to teach people how to conserve the environment, and here we've concentrated a lot on different skills practices in agroecology. We have St. Jude permaculture, practical permaculture, which is also set below St. Jude agroecology. And here we also set up different practices that people come and learn and see and practice. We've decided for a long time, we've been working with the adults and schools, reaching them in their localities. But now we decided to train the young people, the youth, and that's when we set up St. Jude Agriculture and Vocational Center, whereby they stay for 2 years and get either a certificate or a diploma in what we are training. We spend most of our time with the farmers that come to train with us. At least 75% of the time they spend here is spent on practicals, because we believe that farmers learn better by using all the 5 senses, and that's when they go back and implement. And only 25% of the time here is spent in class for theory. St. Jude, after training all these farmers, because every year we get over 40,000 farmers that go through our trainings, we also decided on the side of value addition and processing. So we set up Masaka Organic Producers as a marketing arm of what we do here and what farmers produce, so that we can have a collective market and having one voice on the side of prices. So we have it, and we've always been at least exporting some of what farmers grow and what we grow at the demonstration center, so that farmers get a higher price than usual.
Hello everyone, I'm Daniel, a trainer at St. Jude Family Projects. In this episode, we are going to look at the agricultural practice of post-harvest handling. As you all very much well know, in Uganda, most of the agricultural losses occur as a result of having bumper crops, and then after having a bumper crop, you have a lot of bumper harvests, and then if you fail to add value to what you've harvested, in the long run markets end, and you are left with a lot of crops or a lot of harvests that are not processed into more developed food products that can carry a better shelf life, and you end up losing out on most of the money that you've invested in that for that season. So to address that, St. Jude Family Projects, with the many farmer networks it has and the many farmer groups it has, complaining about the many abundant harvests they receive every season, we had to really roll in a new project of adding value to what we actually harvest. MOP, Masaka Organic Producers, was an answer to address that issue. And Masaka Organic Producers was started in 1997 to come in as a project that would readily add value to what farmers were producing in their small gardens, so that it can command a better price on the market, or even command a better shelf life. So today we are going to look at this process, and we've sorted out some of the crops that we process at St. Jude. First of all, we have the pineapples. We process pineapples, and from a single pineapple we can end up with a number of other value-added products that can carry a better price on the market. For example, we dry pineapple slices, and we are able to sell them at a better price nationally and internationally. We can add value by harvesting the juice out of the pineapple and improving on its shelf life, then packaging it as a ready to drink, a ready to take drink that can be sold in the outside market, again still also in the country itself. So in the background, we have a lot of some of my colleagues actually trying to prepare some of the fruits that we are going to deal with today. We have pineapples, we have apple bananas that are being prepared. In the inside there, we shall be able to see beans that are being put into order so that they can be processed into further products that can command a better price on the market. So we are going to go on inside, and then we see the entire process and how it flows. Thank you. After washing, peeling is done. We remove the outer peels of the pineapple and then proceed on to removing the middle stalk. We remove the middle stalk of the pineapple because in drying it comes off really as hardy and it's not palatable to the consumer, final consumer of the product. After removing that, we now slice the pineapple into 4 equal shapes, 4 equal parts, which we now proceed on to cut into different into uniform slices, which we now lay onto the trays. But before we lay them onto the tray, we make sure we do not get into contact. The pineapple does not have to get into contact with the aluminium tray. We then proceed to the solar dryer. The solar dryer we have is a hybrid solar dryer. In the past, we used to have solar dryers which we were using only one single source of energy. We had those that were using 2 sources of energy, which means thermal and solar. But then the drying would take a longer period of time. So by the help of the president and the government of Uganda, we are able to procure machinery that were hybrid solar dryers that were procured from Austria, and they were brought into the country. These machines have been really, really very handy in helping us solar dry and solar dry in time. So what is done is, after putting everything in order and arranging all the slices onto the trays, we now proceed into the drying chambers. We lay them into the drying chambers and proceed on to switch on the hybrid solar dryer. Some of the products that we process at this factory are actually dried food products, and some others are actually liquid food products. In front of us here we have wine that is processed at St. Jude Family Projects. We have honey that is processed from our apiculture center. We collect honey, fresh honey from our apiculture center and bring it here. And then go ahead to process it into final products like this one, which we sell on the market. We have jam and marmalade that we process from the day-to-day activities, from the fruits that we harvest on the farm and everything. We later on process it into marmalade that carries a better price on the market. This is all wine here. And then we have pineapple juice.
We have a program on sanitation, water and hygiene. As you see, a lot of climate change is taking place. So we need to know how to harvest water, how to irrigate using this water, but also how to keep the safe water for domestic use.
Tulima mu nkuba ng'ebadde etonnya ne bannaffe ne tulima mu kyeya ng'enkuba egenze. St. Jude yatuwa amazzi tufukira ne tufuna emmere ne tufuna enva ne tuguza bannaffe mu budde obwo bo batabeerera n'amazzi ne tuba n'amazzi ne tuba nga tulimanga bo enkuba gye balinda mu gw'omunaana basobole okuddamu okulima. Ffe tuliiko season bammemba ba St. Jude tulima buli season, emmere yaffe ebeerawo buli season. Tulima emboga, tulima kawo, tulima entula, tulima pepa, tulima enva zonna tubeera nazo tufuna ssente.
There is a program on savings and credit. So most of our farmers are taught how to save. It's a culture that we are really implementing and we want people to learn and use always. So they now learn in their respective groups how to save, but at the same time get the loans and paying back, record keeping. So it has helped them a lot.
Twakola ekibiina kyaffe ng'abakyala Superwomen Group. Superwomen tukutuula buli lwakutaano ne tuleka ssente zaffe ne tukuŋŋaanya ayina 1,000, ayina 2, ayina 5, ayina 1,000 tuwerawo ne tubala ne tubaako ne memba wa munnaffe ayina ekizibu naga nti kakati ze tukuŋŋaanyizaawo ba 5,000 mu mpole ya 3 ne tumuwola 3,000 n'agenda abaako n'amaliriza ekizibu kye mu 3 oga tuddizaamu ku magoba bw'aba azikomyawo ne tuzza mu nsawo yaffe ne tulabika nga tukulaakulanye.
We have also a program on youth and environment. We set them in different clubs so that they learn how to really work together and conserve the environment, but also learn how to cooperate and take agriculture as a business. It's no longer agriculture as we used to look at it, but it's now looked at as a commercial way of living. So generally speaking, we are very happy to work with such groups of people and to give such information to people to learn from us. I'm very proud to tell you that there are so many other people that have learned from us. Even politically, we have taken over. People come here to learn, and very soon changes are now seen. The president himself has been here 4 times with his cabinet ministers. The MPs from different constituencies come and learn and bring their people to learn from us. I live very happily knowing that there are so many other people learning from us, and we see that our work will be expanded beyond our reach. Thank you very much. Hello friends, as I wrap up with our farm tour and everything about St. Jude, I would like to share with you some of the challenges that we find in doing such work. Of course, the very first one is the mindset change. Our farmers are ready to hear, to see, but also changing their minds is also some work that we take gradually. So that is number one. That is challenge number one. Challenge number 2 is the illiterate levels of the farmers that we work with. Most of them have not had a chance to go to school. So you find that you have to do a lot. First of all, they cannot read for themselves. So we have always to do things practically so that they see. That's why we are using a lot of demonstrations. They take a lot of time to understand most of what we are giving to them. So it gives us also more time, takes most of our time to concentrate and in smaller groups. Instead of working in a bigger group and giving what you want to give at once, we need to travel several times to the communities to train them on ground so that they can understand what we want to teach them. Another issue is the issue of transportation. St. Jude is unfortunate because we only have one truck, a small pickup that we use to go to the communities. And most times our trainers go at the back of the truck. When it's shining, they feel it so hot and with a lot of dust because most of our roads are dusty. So you find that by the time they reach the communities, they're already very tired and worn out. And when it's a rainy season, the same pickup takes them at the back, and you find that they are now finding it, they reach the communities when they are very wet, and so it is always a problem. Plus the impassable roads, because it's not even a four-wheel drive, the roads are very impassable, and we really get some days our trainers stay out in the field because they cannot come back when it rains. So that is a very big challenge. We rather have some motorcycles that can take them easily and back, but we don't have them as per now. Another issue is that we also have to carry some training materials to the communities, and then it's very hard when they have to go at the back of the truck with the materials, teaching materials, and we need to go, many of us, but we cannot fit very well on the top of the truck. Plus, now a very big issue of the farmers, especially the mothers, having so many children, young children mostly, and you find that sometimes they miss coming for the trainings because they have to take care of their children back home, and mostly the young ones. So we need a lot of emphasis on family planning so that these women also find some time for themselves, and instead of spending all the time looking after the families, and they cannot feed them properly, they cannot have enough money to take care of them. So it's really a very big issue. And working in remote areas, this is what we've been really facing now and again. And I would like also to call upon, because we've been collaborating with different universities, some of them are national, others are international, like Western University. I'm very happy to tell you that we are very happy and proud of working with the Western University. Through Dr. Aliddeki, we came to know the Western University, and the interns that have come to work with us have been very, very helpful. It has been a very successful story because most of them, when they come, they work with us, and we are calling upon other students who would love to come to St. Jude for practicum, and also researchers who would like to come and work with us, would like to call upon volunteers. To you, Dr. Aliddeki, and other professors, you know Dr. Aliddeki is part of St. Jude, and Uganda is a second home, a second home for Dr. Aliddeki. And when we see him at St. Jude, we are always very, very happy and very grateful. And with all the teams that he has brought to us, we cannot have any regrets. So we are very, very grateful to you. And we look forward to working with you so many other years working with the students, the interns that come, and even when you have some researchers and volunteers, please, you're welcome. Lastly, I call upon whoever can donate, or the donors or the funders out there who can work with us, who can partner with the St. Jude, so that we see a great change with the people that we work with the environment. And we think that if this happens, then it will be wonderful. We want to do a lot of research, especially in agroecology, in organic agriculture. Lastly, I call upon whoever can donate, or the donors or the funders out there who can work with us, who can partner with the St. Jude, so that we see a great change with the people that we work with the environment. And we think that if this happens, then it will be wonderful. We want to do a lot of research, especially in agroecology, in organic agriculture, in permaculture, so that people find an answer to the so many issues that are taking us backwards. Thank you very much. I'm looking forward to having so many joining us at St. Jude to empower the people that we work with, to help people help themselves. Thank you, and bye-bye.